friends. Today, let's do one more exercise, and this exercise has to do with functions. Let's see. Consider the function of the set R in R given by the function x equal to m squared minus 4 that multiplies x added to the 12. Now, look at the growth n, or in function of the real parameter. Calm down, people, do not be afraid, but let's slowly understand what the exercise asks. Before, however, let us understand that we have a function of x and y, where y is the function of x. This function may be increasing or decreasing. So, let's see when the function is increasing or decreasing. Being a first-degree function, the line grows from the value smaller to the larger value and decreasing from the larger to the smaller value. See the examples of the following charts. These graphs can be represented as follows: a greater than 0 being an increasing function and less than 0 being a decreasing function. Now, without doing the graphs, how do we find out when the function is increasing or decreasing? It's quite easy to find out. See. When we see the functions, we note whether the value of a is greater than 0 or less than 0. The plus or minus signs can help to identify if the function is increasing or decreasing, but the value of which will actually determine the function. The function of x is equal to sometimes x plus b. Is this a positive or negative function? If there is no minus sign in front of a, then the function is positive. If the function is positive, then it is increasing. If it has the negative sign in front of the a, then it is decreasing. Here are some examples of algebraic expressions, and let's identify the value of a and see if it is increasing, positive, or decreasing, negative. Function of x equals 3x plus 2, so a is equal to 3. If a is a positive number, then the function is increasing. Function of x equal to x minus 5, then a is equal to 1. If a is a positive number, then the function is increasing. Function of x equal to 3 over 2x minus 4, then a is equal to 3 over 2. If a is a positive number, then the function is increasing. Function of x equal to minus 4x plus 2, then a is equal to minus 4. If a is a negative number, then the function is decreasing. Function of x equal to minus x minus 7, then a is equal to minus 1. If a is a negative number, then the function is decreasing. Function of x equal to minus 5 over 2x, then a is equal to minus 5 over 2. Being the negative number, then the function is decreasing. Now that we find out when the function is increasing or decreasing, let's go back to the initial exercise. Function x equals m squared minus 4 that multiplies x plus 12. We see that a is represented by the following equation: m squared minus 4. If the equation m squared minus 4 that replaces the function of a in the equation is positive, the function is increasing. If the equation m squared minus 4 that replaces the function of a in the equation is negative, then the function is decreasing. Let's find out the roots, that is, the values of m in the equation. m squared minus 4. Let's see. We can note that m squared minus 4 is the one remarkable product, the result of the product of the sum by its difference using this formula, a plus b multiplied minus b, which is equal to a squared minus b squared. Therefore, we have m plus 2 times m plus 2 equal to m squared minus 4. Since m plus 2 equals 0, then m equals minus 2. We found a root. If m minus 2 equals 0, then m is equal to 2 more. We found the other root. So we see that the roots belong to the truth set equal to minus 2 and 2. Now, we'll have to study the graph of this function. The graph of this function is as follows. We find the root minus 2 and root 2 on the x-axis. See the image in this equation. M squared minus 4 when m equals 0, the equation has the smallest value, that is minus 4, and that is on the y-axis, being the third point to form the curve of this equation. Knowing the true set roots of the equation equal to minus 2 and 2, when m is replaced by these values minus 2 and 2, equation m squared minus 4 has its value, that is equal to 0. Thus, by substituting m, we confirm the root values of the equation. Let m be replaced by at least 2. M squared minus 4 equals 0. Less 2 squared minus 4 equals 0. At least 2 times minus 2 minus 4 equals 0. Plus 4 minus 4 equals 0. Let's replace now m for 2 more. M squared minus 4 equals 0. 2 squares minus 4 equals 0. 2 times 2 minus 4 equals 0. 4 minus 4 equals 0. We arrived at the solution of the roots. As we have already seen, the values, when they are positive they generate a growing function, and when negative they generate a decreasing function. Now, let's see in the graph. If the function of x is equal to m squared minus 4 that multiplies x plus 12. Is it increasing or decreasing relative to the values of the truth set? We have that function is decreasing in the interval of m of less than 2, knowing that this function has two variables m and x. Note that when m is equal minus 2 and 2, even if x increases in values the equation has negative values and the function is decreasing. See the image. In the graph we can see that the interval between minus 2 and 2, clearly the function is decreasing. Now we have that function is increasing from m negative infinity and minus 2. Let's see the graph. Note that when m is equal to infinitely negative and minus 2, even if x increases in value the equation has negative, squared values, so the function is increasing. In this case this function is increasing even with a negative increase, because by replacing the m with negative number minus 2 the equation will look like this. m squared minus 4 equals minus 2 squared minus 4, that equals 0, then minus 2 squared is equal to 4, which is positive number, so 4 minus 4 equals 0, so any negative number that comes after minus 2 infinitely and raised to the square as an m in this equation, will give a positive number, so the function is increasing. Next we see, in the interval m is equal to infinitely positive and 2 more, we have the following graph. Note that when m is equal to infinitely positive and 2 more, when x increases in value the equation has an increase of positive values, and so the function is increasing. Well, we have that function is decreasing in the interval of m which is equal to minus 2 and 2, but in the interval between m which is equal to infinitely negative and minus 2 where it is equal to infinitely positive and 2 more, the value of the function is growing. See the image. Note that when m which is equal to infinitely negative and minus 2 and m which is equal to infinitely positive plus 2, even if x increases in values the equation m squared minus 4 has positive values being increasing function. Well folks, here we close this exercise. Hope you have understood, and any doubt we are there in the comments. Leave your comment, leave your like. If you wish, if you like, share our videos to assist other students, and we're on YouTube channel Point with Wiser Bar. People, see you next time. I'm counting on you. See you.